Hi again, this is Bill Punch from Michigan State University. This is another video in the series of videos on the topic, the practice of computing using Python, CSE 231. This will be our first video on the topic of scope in unqualified namespaces, and we'll follow it up with a video on qualified namespaces. Let's go ahead and get started. So the first question we have to ask ourselves is, what do we mean by scope? And the definition of scope is that there is a set of program statements over which a variable can be referred to. That is, there are some statements where a variable is defined and some where they are not. And the key to understanding how Python makes that decision is that Python actually maintains multiple namespaces at any one time. Our goal is to search through the namespaces in a particular order to see if a variable or a function is defined. If we make the pass through all the namespaces and cannot find that variable, then the variable is undefined. It turns out that there are two different sorts of rules depending on the kinds of namespaces we're working with. We're going to talk about unqualified namespaces, standard assignments, and functions. We'll talk later about qualified namespaces for things that work with classes. For unqualified namespace, there's a simple acronym that we can remember to remember the order. This is the order of namespaces that we search to try to find the definition of a variable. Local namespace, enclosing, global, built-in. The acronym is LEGB, and this then is the order of search for namespaces that we go through. Let's take a look. Here is the example of a local definition. Here is a function. The function is defined with three local variables. The parameter string, that's considered a local variable. A string because it's assigned inside the namespace. New string because it's assigned inside the namespace. Those things all are a part of the local function namespace. They exist only while the function runs and do not exist outside the scope of the function. When we run this, we get our results back. We get a definition for new string, we get a definition for a string, we get a definition for the parameter string, and we get the result back, which concatenates them together. If I then want to print the parameter string in a global namespace outside of the function namespace, I get an error. It is not defined outside of the local scope. In closing, even though this is kind of odd, is the idea that you can define a function within a function. So here's our first function definition, and inside of that function definition is another function definition, a very simple function definition. This function, function inner, is defined inside of the function namespace, and so is local to the namespace of the function. It's only available to someone inside of the namespace doing the work. We have two variables here, var underline string, one defined in the inner function and one defined in the outer function. LEGB says if it's not local, then to look in the enclosing function namespace, and so inner is completely enclosed by outer. If we run this function, we get inner because var is defined here in inner, and we print it. Were we to comment this and run it again, we would get the result outer. We looked first in the local namespace and did not find it. We then looked in the outer namespace, did find it, and printed it. Note that if I try to call inner in the outer namespace, I get an error. It's only defined in the function local namespace. Here's the same piece of code with a third value in the outside. Let's go through it in order. So we have var string inside inner, we have var string inside outer, and we have var string at the global namespace level. We run the same functions that we did before. The way it works the first time, we get inner. If I comment this one out, LEGB says look up to the enclosing namespace, we get outer. LEGB says if we comment this out, we look to the global, and we get the global namespaces. So we've looked up three namespaces, first the inner, then the outer, then the global namespaces, and Python will do the search for variables in that order. Lastly, same sort of setup, but we're going to use the built-ins. The built-ins are those things defined by Python to do the work of Python, integers, strings, all those sorts of things. In fact, what you can do is if you want to import the built-ins module, you can print a directory of those things. And these are a list of all the things that Python gives us by default before any of the packages or modules are imported. So these are all things that Python knows about, knows how to work with, and has available to it whenever it needs it. Note, for example, that true as a variable is defined within here. Let's change our little function one more time. The only change is that now, instead of printing the var string, we're going to print true. True is not a variable defined in this space, it's not a variable defined in this space, and it's not a variable defined in this space. It's a variable that's defined in this built-in space, and when we run this function, right, get exactly the right value. The variable out here is global, but the result returned is true, found in the built-in space. One more thing. This is a difficult thing to understand, but let me show you the example. We have a function that does two things. There's a myvar global, there's a myvar local. When the function runs, the first thing it does is print myvar, and then it reassigns it. Your expectation, I suppose, is that when we do that print at line 3, we get global, but instead what we get is an error, which is surprising, but the reason why is this. When Python creates a function definition, it looks at the entire space to see if there are any assignments that have been made. And if they are, before it runs, it creates in the local namespace that variable and says it's local. At the point of actually running the code, then, it goes and runs the function, and it goes to print, and myvar has no value associated with it yet, and so you get an error. The point is that Python does this in two stages. First, it does the examination to see is there anything that's going to be assigned in here, and the answer is yes, and it's made local no matter what. And then at the point of running, the first place it looks is in the local namespace, and whether it's been defined or not is got to be done locally. The bottom line is if you define a variable locally, no matter where it is in the function, for all of the statements in that function, they will act as local variables. Lastly, then, there is a special keyword called the global keyword that allows us to get around this. If we use it, for example, on line 3 here, we've said we want to use the global keyword, and what that says to Python is that even though an assignment was made inside this space, I want my variable, the variable called myvar, to be used globally. So I will keep myvar global. When I print it, it will print the global value. When I set it to 27, it will change this as well. So if we run that, and the last thing I did was print the value of myvar at line 8, we'll notice that the value 27 was returned.